and thank you for joining my session. Today, I will talk to you about refactoring to design patterns. So, the question of refactoring to design patterns is very important because I see that many people are making mistakes about both refactoring and design patterns. So today I will show you a couple of slides to tell you the backing theory, why we use design patterns, when do we use them, and when do we refactor. And after that, we will switch to code, where I will show you one demonstration how design patterns can appear naturally in the design and how refactoring is used to help reach the design which is applying patterns correctly. So the design patterns, when you work on whatever requirements you have, you will normally produce some code, and many people tend to introduce design patterns right away. They read requirements and they apply patterns. They transform requirements into patterns. And as you will see during this demonstration, the mistake will already be made at that point, because my question always when it comes to design patterns is, what patterns? Which patterns do you see when you read requirements? Because your customer will never ask you to apply any particular design patterns. They will ask for a piece of code which works. So I'll give you an example, an abstract factory. Why do you want to have an abstract factory in your code? You see, you have the client which is using an abstract product, applying an abstract factory to construct it. Behind the scenes, there will be a concrete factory injected, which is creating a concrete product. Why do you want this? Especially, why would you want to have this if you know that talking to an abstract product is by definition more complicated than talking to a concrete product? For one thing, abstract product will certainly miss some details of the concrete product. So why do you want to have it? It will complicate your design. For example, virtually all books on design patterns are mentioning this example, a GUI factory, a factory for graphical UI elements. You want to have a button, an abstract button. But if you are working on a Windows system, you will work with the Windows button. And then if the client wants to really work with a Windows button, it will eventually need a window handle. But the window handle doesn't belong to the abstract button. That is what I said previously. It becomes hard to talk to an abstract product. So the abstract product will now have to accompany a cross-system abstract handle, which will have a concrete Windows handle below on your concrete Windows system. So why do you want to have such a complication in your design? Why 7 types if you only wanted to have 2 types to work with? That is the curse of design patterns. They are inflating your design. You don't want to have them before it is certain that you will get the benefits a pattern is offering. So the benefit of an abstract factory is to support 2 distinct products. So the question is, do you have 2 distinct products, and is the abstract factory the right way to produce them? If yes, then you will either see this or this, and then you will have some flexibility this pattern is promising. The question is, again, do you need this flexibility? And then, why abstract factory? If this is the flexibility you need, then I will tell you straight, there are a couple of options there besides abstract factory. I will give you an example from the project which I'm working on these days. It is about editing sound. When sending sound to some device, you have some options like saving it to a file, or sending to a network service, or playing it on speakers. That is where abstract factory can be injected so that it can create one or the other concrete sound device without the client depending on any of them. So that is good. But again, why abstract factory? This is one option. What if this sound device was an isolated concept? Why not a factory method? Or why not injecting a strategy so that the client doesn't even see this object here? So there is no connection here. The strategy could create and use the sound device, concrete sound device, and that's all. So the client doesn't even see the product. That's a completely different mindset. Or why not turning the client abstract and implementing concrete clients with their own save methods, which are producing and using sound devices, again, making sure that that the abstract client doesn't see concrete or abstract products. So you have at least 4 distinct patterns to apply here. If you read the user's requirements and apply one particular design pattern, you will get the flexibility offered by that pattern, but you will lose all the other flexibilities that are cut by that particular pattern. And you may have made a mistake because you still haven't reached the point in your design when you do need flexibility. And what if it turns out that the flexibility you will need in a week or in a month is not the flexibility you have just injected into your design? You will have to write it all over again. Let me show you again an example, this example with sound, and I will show you code which demonstrates this line of thinking. You will start with user stories, supposedly. So the user will want to compose sound, and you will write a piece of code, which is, I don't know, producing sound. And you will want to debug it. You will want to save it to disk as an uncompressed. You don't want to complicate your code. You just save a wave file and listen to it. You don't show this to the customer. This doesn't go to production. But you have one feature implemented. Then comes the next user story, which says, I want to save sound to disk. And then you say, now observe that on the right side where there is code, there are no design patterns. You don't need them. Nobody has asked for any special kind of flexibility, so there's nothing special to do with the design. Just implement what was asked. Okay, so the user wants to save sound to disk. But you only have the raw sound, which is uncompressed, and you must compress it. So now you add a feature, and the file name will not be the wave file and will not be the debug wave. Somebody will have to tell you the file name, and that becomes a parameter to the algorithm. So a very important thing that many people slips from many people's minds is that you can make your design flexible by using parameters. You don't need any patterns or any special design elements. Just pass the parameter. And you can make this implementation flexible enough by only parameterizing its function. And then comes the next requirement. The customer wants to hear the sound. So it's not to save it to disk and play manually, but wants to play it while editing. So you will add the play function, but play on what device? You need to identify the device on your system which will receive the sound and play it. And now we see that something strange is happening. We are having 2 kinds of parameters, and that is the place where parameterization ceases to be useful. And then we jump in and implement a design pattern because we have 2 kinds of behavior which cannot be put into one class. And then we think, which design pattern? Is this sound editor a reusable component? Or is that is that sound device, whatever it is, the file on disk or a media player, is that a reusable concept in your design? If it is, you might think of using some kind of factory. Then, is that device an isolated concept? If yes, then just pass in a factory method, or if it is part of some larger bundle of classes, then use abstract factory. Otherwise, if it is not reusable, if this editor is only going to save or play the sound, then we could think of some kind of a strategy. Is this sound editor doing only one thing? If yes, then you can use the template method. If not, then inject the proper strategy into it. What I want to tell you is that you can see that this thinking only came after quite a large body of user stories was already implemented. I never needed any kind of special flexibility here, so I didn't apply any design pattern. But when the troubles came, then I had a lot of information about the way the application will be used and about my particular design, which I have right now. And then I can apply some thinking, some qualified thinking to apply a design pattern which is just right for my situation. That will increase my chances of survival later when a new requirement comes, like the user wants to send sound to an online library. Okay, how will my new design, with whatever design pattern I applied, will survive this? Well, if I was right, then it will only mean that I will add one component to the design and nothing else will change. If I wasn't right, then I will have to redesign the previous solution to make it possible to add a new component to it, the new concept to it. So basically, you are applying design patterns when you have information what kind of flexibility you need. And once you clear that, you will probably have one or two design patterns which are natural candidates for your design, and you will simply apply them. If you were right, then subsequent requirements which are which make sense in relation to previous requirements, they will naturally fit into your design. If you were not right, you will have to redesign your application and start some parts of it again. Okay, that was a theory. Now let me show you some code. I will, in this demonstration, develop that sound editor, which is following a bit modified requirements, a bit different compared to what I just shown you, because I want to make it more interesting. But the first requirement remains. The user wants to generate some sound, and you would do whatever that means. You can imagine 7,000 lines of code behind this line. But in the end, a couple of weeks later, you will have a sound generator, whatever that was. And as I said, you will want to probably hear it. So you will add save for debugging, a hidden method which will not be deployed to production, where you will save the sound into a debug.wav file, which nobody will see. Only you will be able to see whether the rest of the application is doing well. But this is the entire first requirement. Again, there are no design patterns here, except maybe in this implementation, but I'm not interested in that right now. Anyway, we are done with the first user story. The next user story is to save sound to disk. So I already have something similar. I will rename it to save. You will see that I will be using ReSharper all the time during this demonstration. I will use many features of ReSharper as promised in the title of this talk, but I will not talk too much about those features. I hope if you're using ReSharper or any other tool that you will get the point of particular refactorings I'm applying. Anyway, I have some save method, but that will have to compress sound. It doesn't make sense to save the WAV file to disk, so I'm adding new feature. Observe closely what is happening to the code. Which pieces of code I'm adding and which pieces of code I'm modifying. Because as a programmer, you never want to modify code. If you modify code, you will add bugs. You will introduce regressions, things that used to work will stop working or will start working differently. People will get annoyed and stuff like that. You know that. So you don't want to touch code which was designed well and implemented well. But right here, I have to modify my previous implementation. So I will invoke compression. This debug wave file will have to go. You see, it doesn't make sense to tell where to save the file, but I need some parameter. And I will add a property to the sound editor. So the sound editor will be destined to write sound to one particular file. Destination will become a parameter of this object, and it will be set through the constructor. And then I will effectively write to that destination, all right? But I had to change both lines of code. So whatever logic, whatever domain logic was here, I will have to modify it. And that is the dangerous part when you have a new requirement and that requirement fits right into the class which you already have. Then you are in the danger zone. You will make bugs, you will make problems. But all right, that is part of our life. We have survived this, and this requirement is done. But then comes a much more complicated request, and that is to play the sound. That is not compatible with this implementation. We'll have to come up with something new. So I will introduce, I'm still in the same class, you see. I'm adding a new play method. Not just save, but now we have two behaviors with the uncompressed sounds. The same state is being transferred to two distinct processes. Remember that this process save was already parameterized at the object, at the class level. The object has the parameter, but this one has its own device ID. Why? I want to unify these designs, so I will expect both play and save to have their particular parameters in this object. And now we have two incompatible behaviors. That is where parameters will abandon you, and you will have to think of a more flexible design, a different way to inject behavior. So I will retain this idea of holding the parameter as part of the object. But then, since I have a file info as one parameter and an integer device ID as another parameter, it looks like I will have to have two classes, one with file info and the other with integer. So I will derive a class. And I will call it File System Sound Editor. It will do what my classes is currently already doing. So I'm pulling behavior down into a derived class. How do I do that? I will, what I said, pull behavior down in ReSharper terms, that is pushing behavior members down. I will push this save behavior down into this derived class. And since I already know that playing will be just a different kind of this behavior, I will make it abstract in the base class. So you can see that I'm refactoring in such a way that I'm already supporting adding the play function, but in a different class because it pulls its own parameters with it. Save will require compress, and it will require destination. So let's see. Okay, it's warning me about some things. Save will become protected. I'm fine with that. And destination will be a problem because you will see what will happen anyway. Destination is now a parameter of the base class, but base class should really not depend on it. I will delete this constructor and initialize destination here in the derived class. What happened here is that now I have all that behavior which I used to have in the SoundEditor, the only SoundEditor class, but now it is encapsulated in a derived class which depends on its own parameter. Save method has become abstract in the base class. I will make its name more abstract too. I will call it persist. Not too smart, but I don't know. In a sense, it doesn't promise to save sound anywhere. If you don't like any name, don't worry about it. Renaming it again will be another 3 seconds of your life, so don't worry about names too much. Anyway, play function will be just another implementation of persist, so I will delete it from this class. This class will only have the persist step. I will move this file system SoundEditor to its own file. And let's see what we have got. We have an abstract persist method on the base class, which is used as one step in a larger algorithm. What is that? It is the template method. This function, this method, is a template method. And concrete implementation of one step in the template method is this. Did I have to mention the template method design pattern while doing all this? No, I didn't have to. Do I have to use that name right now? Maybe, if I wanted to make me more clear, because you know the template method the design pattern, and I don't have to explain you how this method is going to work. But that is all. Besides improved communication, I don't see much value in design patterns. Honestly, if you insist on design patterns too much, you will probably fail to see other elements in your design, and you will probably make more mistakes than if you just didn't think about patterns at all. So what I effectively did was to pull out a few members, to fix a few mistakes, to make sure that I didn't break any of the classes. So this was a dangerous move. That's what I want to point out. But in the end, we have a design which is more flexible than it was. Before, it was parameterized through the constructor of the only class. We have hit the wall there because the second incompatible parameter could not be injected. So we moved that parameter to an object. And now we can implement a different kind of a sound editor, and that is the player, which has the device identity, a different incompatible parameter. And now we implement that abstract step in the template method any way we like. Again, you can imagine a few hundreds of lines of code here. But after, what I want you to see, that after I created the template method and one concrete implementation, adding the second concrete implementation was a piece of cake. Nothing else in this solution changed by introducing another concrete implementation, another concrete derived class. And that is the benefit of not just design patterns, but of the design. When viewing any design pattern, you're actually trying to see a single important element it is adding to your design. This application of the template method pattern is adding independent parameters to my design. That's what I needed, and that's what I have now. It is closing the door for many other things, and one of them you will see in a minute. The point is that any design pattern you choose to add to your design will make it better in one respect and worse in all the other respects. So, the next request. A user wants to be able to add a segment of sound to whatever he is editing. I will, for example, add silence, because when producing sound, users want to add a second or two of silence at the beginning and the end, and a real sound in the middle of that. Now, that is completely different compared to what the previous request was. I mean, the previous request was to add the entire sound, and it was very easy. If you go to File System Editor, adding the entire stretch of sound means just to write all bytes to disk. That is very simple. Now, if you have some knowledge about sound files, you will know that you cannot just append bytes to a file on disk. It will simply not be all right, because sound files have headers. They may be compressed in a way which must be decompressed and recompressed again if you are adding parts of the sound and stuff like that. So it's not so easy. This request in my application is quite different. And there is another important element in this request. This add silence will be invoked several times. Generate tone was supposed to be invoked only once, but this one will be invoked several times. So now you can imagine using the application, using this class this way. Add silence, then generate tone, then add silence. There is a time protocol, and that is what you will often hear it to be named as the protocol. When you have a protocol of using some specific class, then you have much wider range of problems compared to using a class with only one operation, which is called only once. You will have a long-living object, and you will see the template method will not be able to support that. But we still don't see it. We might say, oh, this previous design worked so well for us. Let's add the append method. Let's construct another template method and simply append silence to whatever device we are using. The problem is that this simply won't work for the reasons I just explained. You cannot just append bytes to a sound stream. It won't work. We need something better. And when you need to support a protocol, you will probably need a subordinate object which will support the part of the protocol you need. And I'm speaking abstract right now. I'm not sure whether you can follow me, but okay, let me try to repeat it. This sound editor must support a time protocol. It cannot support time protocol because it doesn't know what device it is talking to, because every device will work by following a different kind of protocol. And so it will have to pass that duty to somebody else. When you say somebody else, that is another object. It is not a derived class, because a derived class will share the same issues this class is already having. I want this append to be defined on some other object and let that object manage the protocol alone. Okay, so append will be defined somewhere else. It will not be an abstract method. I'm doing this refactoring this way because that is how ReSharper will help me do it. It's not necessary. You can do all this manually. It will take a few minutes more than what I will do right now. So I will turn the append method non-abstract. I will extract a class, and I will call it file system sound sync. It will be a sync for the sound. It will just receive sound from me, and I don't know what it will do with it. But what happened here is that now I'm calling append on something else, on an object. I have pulled out an object. Okay. But I don't want to talk to file system alone. I want to support different kinds of sound syncs, like speakers or headphones or network connection. So I will, in fact, extract an interface and call it an iSound sync. And I want this interface to have this method on it. Here it is. This is the abstract sound sync, which will supposedly support appending sound to it. Then I don't want my sound editor to depend on a concrete class. I want to use the base type, not object, but sound sync interface. Here it is. And I don't want this to be the field. I will encapsulate it in a private property. Here it is. I have completed this refactoring, and now comes the next step. This file system sound editor will be promoted to a sound sync. It will be following its own protocol about compressing, decompressing, doing whatever stuff needs to be done. So I will eventually make it implement that interface, not derive from the sound editor. So I want to have this sound sync to be initialized to a concrete instance of the sound editor. But I cannot do that because, you remember, this sound editor requests a file info, and I don't have it. We are missing a mandatory parameter here. So we will have to do something else. Template method will not work anymore for us. I will delete this class. It was only used as an intermediate step to help derive this interface with the only method I wanted to have. So I have completed pulling out the sound sync concept, but my code doesn't work. Instead of instantiating this sound editor component, I will choose to use the factory. Before that, let me clean it up a bit. It will not be the sound editor, it will be audio file. It will be just a file. It will implement the sound sync interface. So to remind you again, remember when I said that when applying a new pattern, you will have a part of a stretch of time when you are modifying code, exposing yourself to danger, well, this is that period of time. I am elevating one class to do something more than it used to do because it doesn't support the new requirement. It cannot be used as part of the design which is implementing the new requirement. So I am in danger right now, and I must think how to modify this class, how to augment it with minimum of changes made to the substance of it. This is the substance. This is those 7,000 lines of code. I must not touch it as long as I can sustain not touching it. Anyway, this method persist will become that append method, and then I will have to change these things. This stretch of code will be affected by the new not refactoring, redesign. So now I will be really in danger. This will simply not work when working with sound. I explained that. But once that is done, this class will support appending uncompressed sound to an existing stretch of sound. But now that it has a time protocol built into it, it will have to be disposable, because it will not just write, it will write many times to the same file. It will hold the file handle open, which augments the design even more. The sound sync will say that it is disposable. You see, this will affect the one who uses that. The sound editor is using it. So now it will use the disposable component. It will complicate it even more. But anyway, I will implement the dispose. It is empty now because I'm just pretending that I am appending anything to the file. And this class will effectively be done. I have augmented one element of the design. This audio file, which used to be a file system sound editor, is now a separate concept, not deriving from the sound editor, but doing something completely different. It is effectively offering a strategy to append sound to an existing sound. And now is the time to apply a factory. So the sound editor will have to receive a factory for this. And when it comes to using it, it will have to instantiate the sound sync if it wasn't instantiated already, and return it so that the append can be called on it. This time you can see that I'm using this append as a strategy effectively in a larger algorithm. Writing the entire or generating this tone will also append that tone to the file. That's all right. This persist method will not exist anymore. And now comes the second part of editing the sound editor. For one thing, it will not be abstract, but it contains a disposable component, so it will have to be disposable. I will implement dispose. If sound sync was effectively used, it will have to be disposed. And this completes the redesign. There is another component. You remember this sound player. It will have to pass through that same torture, becoming a kind of a sound sync, appending sound in a probably different way, and disposing of it at the end, like closing the device which it was using to play the sound. Anyway, I have completed not only the refactoring, but a pretty large redesign. And all that for the sake of supplying this new method. I simply had to do that because the previous design didn't support it. And that is the curse of design patterns. When I applied the template method. I was probably right to do that. But as you can see, the customer came with a completely different requirement that wasn't perceived upfront. They asked for a different kind of a feature, and my design didn't support, wasn't flexible in that design. So what do? Well, you spend a week redesigning a part of your application. Good news about that is that if you were designing your application, your code in a decoupled manner, if your concepts were already isolated and decoupled one from the other, then the redesign you will have to apply will probably be located in a small piece of your application, not application-wide. So that is one good thing that comes from design patterns, even if you make a mistake. And the second thing here is that that danger zone you will have to pass through will be smaller, because you will probably try to find ways to augment one class or two classes or one interface and a few implementations of that interface. You will not have to augment the entire design all at once, because that might take a month. But you will be able to work in smaller steps. You could, if you have a large design with 1,000 classes, and maybe 100 of classes will be affected in the end, you could start bottom up, augment one class after another, one interface after another, with minimum disturbance to everyone who is using those, and then progress your change through the design until maybe in a month you have augmented the entire design, but in very small steps, much safer steps than if changing 1,000 classes all at once. You will probably be able to release your application several times in that period. And in the end, you will have the augmented class. If you read Martin Fowler's book on refactoring, you will certainly know that Mr. Fowler is using one word very often, that is the word seam. You should add seams to your design. Those are places where you can inject new behavior, pull out a method, pull out an object. That is exactly what I did. And in particular, template method has offered me a seam, and I didn't plan to do that. It simply happens. Why did it make that seam available to me? Because template method is decoupling the large algorithm from one particular step in it, and that step was the seam. And injecting the protocol was in effect done by pulling out that seam and turning it into an entire object. So this was again a lot of theory, but that is how design patterns and design elements of those patterns are working. I will complete this presentation by simply showing you how this editor can be used on the client side. I want to instantiate the editor by newing it, but I cannot because it is asking for the factory. All right, I will prepare a factory, a func delegate, which is just instantiating the audio file. Now you see that connection between the sound editor and the abstract sync, but not with the concrete sync. This editor will not know that it will effectively save a file on disk. However, this audio file is requesting the destination, the location of the file. So I will inject file info into the audio file, but not into the sound editor. And now we have that decoupling. So when we put the sync factory here. There is no connection, there's no dependency of this object on this one object. And you will see how I will use that in a minute. Anyway, SoundEditor is now disposable. If you used SoundEditor before append was added, now you will have to modify the client as well and to put it into the using clause because it has become disposable. That is the problem with redesigns. You're breaking clients. You're breaking clients sometimes in ways that are not easy to spot. If I forgot to dispose the SoundEditor, maybe no tool will issue a warning to me, and I might deploy this code to production, and it will not work well. You will see why. So if I instantiated the editor, I could add 2 seconds of silence, add some tone, add another 2 seconds of silence at the end, and dispose of it. If you remember the design, disposing of the sound editor will trigger disposal of all the resources effectively used under it. In a way, if I saved that to a file on disk, that file will that sound will be encoded and written as MP3 on disk, and I will be able to open that file will be unlocked on disk after dispose, and I will be able to open it and listen to it. That is how my design is working now. But what if I wanted to hear it while editing? No problem. Just change this, nothing else. The editor cannot see the change because, again, it is not coupled to this 0, which is probably a default sound device on computer. It is not coupled to that. That is a private property of this class. And I suppose when this dispose is hit, I suppose that will finalize pushing the sound to the sound player on my computer, and although all the resources here will be disposed of, I suppose that my speakers will play the sound for another half an hour or whatever. That is the protocol. This sound editor is not bound to. That is what I want to explain. So this use of the class, which incorporates several design patterns, will not be changed through the lifetime of my project. That is the benefit of design patterns. Okay, there was a lot of code here. I hope that you have followed through. I have left 10 minutes almost for your questions, so you can ask whatever you like. Martin will send and ask the questions now. If you wanted to know more about design patterns, I have 5 courses published, 2 of them on Udemy about design patterns and refactoring to patterns. I have 3 other courses at Pluralsight, total 25 hours of video courses. So if you wish to learn more, be my guest. Now, your question, it's your time.
All right, Zoran, first of all, thank you for a very, very interesting session. As promised, I will send you the questions on the private chat that we have as well. First question that I got from people is for doing all of the code snippets during your presentation. Is that your Visual Studio extension you're using?
Yes, that's my Visual Studio extension, and hopefully it will it will be less annoying in the future if I get some time to improve it. Thank you.
All right, perfect. The next one is, how does all of this relate to using solid principles?
Well, if you take solid principles, refactoring principles, design patterns, you will see that they are speaking about the same set of things. That is why I rarely ever name design patterns, because it's not the design pattern that matters. It is that single or those 2 or 3 principles it is applying to your design that matters. So when choosing the design pattern, you will choose the pattern which is improving your design in respects which you need. If you need any of those solid letters, if you're lacking it in your current design, then you will effectively uh, apply a design pattern which is improving that aspect of your design. Most notably, design patterns are improving flexibility. They are turning one thing from your design into an object, invariably into an object, and then you inject one object or the other to vary behavior. Sometimes those objects will implement interfaces. You will sometimes segregate interfaces, but invariably you will decouple one piece of code from the other by injecting some objects. And I don't know if you remember any. I don't want to make this answer too long. If you remember any particular principle from the solid from explanation of solid principles, you will see that in many design patterns. That's what I want to say.
All right, cool. Another question was on that SoundEditor class. Why are you depending on a SoundSync factory instead of only using the iSoundSync?
That is an excellent question, and thank you for asking, because I have forgot to explain that. That is an important aspect. You use factories when you want to control the lifetime of an object. If an object is locking resources, but you are not certain that you will effectively need them, especially if that object is disposable, you will probably be better off to send a factory rather than an object itself. Particularly when speaking of disposable objects, the one who creates it should be the one who disposes it, or otherwise those two pieces of code could go out of sync, and you might forget to dispose disposable objects. So it is safe. It is a kind of safe programming technique to dispose, to let the one who is instantiating an object dispose that object. If that object, like this sound editor, is using the disposable resource over its entire lifetime, then it becomes disposable too, and disposes the disposable resource in its own dispose. So disposing becomes transitive. If sound editor received the sound sync, then it wouldn't dispose it. But if you remember, it created, it invoked the factory only on first use. And that could be a few minutes later. So you don't want to lock the file on disk or to establish a network connection before you effectively start sending something over it. That is the reason why I use the factory.
All right, cool. Thank you very much. Then more of a philosophical or personal question, I guess. What's your opinion on using composition over inheritance while building a first iteration of your design?
Yes, I like composition a lot, but it is making the design more vague, more hard to comprehend. On the other hand, derivation is good as long as it is limited. If you start deriving at 2 levels of depth, you will probably have a wider range of problems caused by the appearance of the second level of inheritance. I have an entire talk on inheritance versus composition, so you could watch that. The short answer is, if you are inheriting only one level deep, you will probably be able to get away with it with nobody really noticing that you have used inheritance, and without incurring the problems of inheritance on the callers. When you start making deeper hierarchies, inheritance hierarchies, you will probably begin making problems to your callers. Again, watch that talk. It is going in great depth what happens when you inherit and what happens when you compose objects.
All right, cool. Then a more practical question from a lot of people actually: is the demo project that you used available publicly somewhere on GitHub or on your website?
I will put it on GitHub. I will do that in another 1 hour, so you can find me on GitHub and look there. It will be there.
All right, perfect. Maybe one more question before we wrap up, and that is related to the design choices that you made during the presentation. Would you do big changes if you want to do both things, like save and play with the same sound editor?
Oh yes. Well, that would have to if you start thinking about how to do that, then you would have to add more details to your request. What does it mean? Does it happen simultaneously? If yes, then that is a very simple thing. Then you make another sound sync, which is just receiving 2 sound syncs and passing every call to both of them. But if there is some more complicated protocol, like playing until something happens, like this pause, then passing everything to the second one, then you will have to implement a special sound sync, which is implementing that protocol. But again, it's all about protocols. In programming, you're always looking at the lifetime of an object and what responsibilities it will resume during that lifetime. If one object is doing one thing, it will probably mean that you will call one method on that and be done with it. And that is great. You always want to have that. But if you have a protocol which supports multiple invocations, and sometimes those invocations depend on each other, like it's not possible to pass sound without specifying how long silence it should be before, then you will have troubles. So stay away from time protocols as long as you can, and when you have no other choice, then use a bigger hammer and implement them. There is no happy path there.
All right, cool. Yeah, maybe one more. I guess we still have a couple of minutes, right? Aside from adding automated tests to this project, what could you do to reduce the danger zone even more?
That is a good question. Again, you are reducing danger zone by reducing your classes. If you have a class with 20 lines of code, then you will probably not make a mistake when changing it. If your class has 100 lines of code, many functions calling each other, then you will be in much larger danger. So if you can focus on doing one thing per one class, and if there are a couple of things to do, then making another class which is receiving through composition another couple of objects and passing calls to them in specific order, then you will have a bunch of small classes, and it will and your change will only affect a couple of them, not all of them, probably not all of them, and you will be in much better position to make the change, a large change, in small steps without causing much trouble.
All right, perfect. Thank you very much. Yeah, I guess we can wrap up here and switch back to my screen. Thanks again, Zoran, for a very interesting session. I think we could host you every day in terms of sessions.
I'll be glad. Invite me anytime you want.